Okay, so we're going to take a look at identifying a function from a list or table this time. So the last video, 2.1b, we identified it from a graph, and this time we don't have a picture, so we're going to need to use our understanding of input-output and what's okay for a function. So let's take a look at this. I'm going to actually choose to make what we call a mapping. Here's my x and here's my y. When I make a mapping from a function, with the ordered pair, which is what I see, I never replace a number. I never rewrite a number. For instance, here's my domain, right? 2, 3, and 6. So I have unique 2, 3, and 6. When I write my range, I have a 1, a 5, and a 1. I'm not going to rewrite 1. I'm just going to put a 1 and a 5. So I never repeat numbers when I make a mapping. All right, so let's take a look at this mapping. 2 maps to 1, 3 maps to 5, and 6 maps to 1. All right, now we talked on 2.1a about this open beak, closed beak thing, which is kind of a silly way for me to illustrate whether something's a function. But let's just take a look at why a closed beak is okay and an open beak is not. This is, by the way, yes, a function. It's a function. Yes, a function. Here's why. If I plot the points over 2 up 1, and then I plot the point over 3 up 5, there's that, and then I plot the point over 6 up 1, you notice that that passes the vertical line test. I could pass a vertical line through that at any point. I would never have 2 points lined up vertically, so it would pass. So this is fine. Okay, so let's take a look at this next one. So that's why it is a function, because when I look at the graphic of it, it does pass the vertical line test. And this evidently, this closed beak right here, only created 2 points horizontally lined up, but didn't create 2 points vertically lined up. Okay, so let's take a look at a mapping of the next set here. All right, so I'm going to go, let's see, looks like I have a 2, a 4, and a 2. I never rewrite twice. So there's a 2 and a 4. And then I have a 1, a 5, and a 6. All right, so 2 maps to 1, 4 maps to 6, and 2 maps to 5. So this right here is an open beak. That says that that is not a function. Let's take a look at the why, right? It's not enough to just know. We need to know why. So we're going to go over 2 up 1. We're going to go over 2 up 5. There it is. There's the culprit. That's why it's not passing the vertical line test. 2 map to 1 and 5. If I go over 4, I go up 6. And so that one's not a problem. But this is the problem right here. So it is no, not a function. All right, let's take a look at this last one. This is a little bit harder to make a mapping of because it's a table, and we don't just have one item here. We have a range of items. So let's just see if we can create, this is the quantity, this is basically the x, right? The quantity, and this is the price, which is basically the y. All right, so let's take a look. Here's the goal, can I create an open beak and satisfy the conditions? Let's see. If I have 2 items here, let's say I have 1, 2, and 3. Okay, is one item, let's see, one item, it looks like they're giving me a discount, right? If I buy more, I'm going to get a discount. So that's kind of a normal thing for retail places. Okay, so if I buy one item, it's going to cost me $8.75. If I buy 2 items, it's going to cost me $8.75. 3 items, it's going to cost me $8.75. If I buy 3 items, am I ever going to have a situation where it costs a different amount? No. So I can't make an open beak. So this right here is a function. All right, even though we don't have specific points that we can look at, we can try to create an open beak. We're never going to be able to create an open beak here. Okay, so the price is a function. I can say it this way even. Price is a function of quantity. Price is a function of quantity. All right? So you can, again, think about that as a result. It's a result. That price is definitely a result of how many you buy. Let's hope so. All right, hope this helped. Thanks for watching.